Okay, so welcome to Rust Meetup Malaysia, May May Meetup, and there are two talks today. I'll be talking first on pyoxidizer and later on how to implement third-party traits for third-party types and something around there. And first, pyoxidizer, right? Pyoxidizer is a tool for packaging and distributing Python application. It's a bit similar to like the CX freeze, but pyoxidizer works for more platforms due to like how their mechanism work, like an implementation here. So for use cases, right? First of them is deploy single binary Python projects. So one can just like run a command and it will create a single binary for the Python project. And others include you can package Python project together with the dependencies into a single binary as well. And do some Rust integration stuff. Like you can run some Rust code. I believe that's what they say. I'm not sure like how much is that. And first, the installation. There are two ways to install this. One is through pip, Python pip install pyoxidizer, and another is through Python cargo install pyoxidizer. And another or can also install through package manager. So I install through cargo, and first impression is the docs is a bit confusing, and regarding the usage, it's like missing quite a huge part like how to get started with a like Hello World Python project. They just get you the docs. Hello World is just to get you to the interpreter level. Like when you run, it'll get you to the interpreter, and it's a bit confusing that there are two entry points. The first being init config file, and there's also another one, init rush project. So I'm also confused when I first see it. And there are two parts. So init config file creates a blank project with a config file, just like a single file there. And by default, when you build or run, it will default it to the Python interpreter. So it will run the Python interpreter, like in a single binary. And the Rust project, on the other hand, right, it will generate some Rust code with the same config file and with some Rust code like src main. And inside the Rust code is calling the Python interpreter using their own API. But I don't even know. I don't know why do they need to do it this way. Not sure why. It also does the same thing. It also invokes the Python interpreter. But rather than doing it through the config, it some parts of it does it within the Rust code. So compared to others that I tried previously for packaging Python binaries, right? This is a bit harder, way harder, but there are more features from what they say around Python and Rust integration. Okay. So skip something. First, slow. So the project is slow, like a snail. And yeah, just side tips. Maybe I'll just do a demo and to see how it works. Yeah, you can see like pyoxidizer. The usage is just like hello world that you just show like this, and it will be just like it just runs the interpreter. So now we will see like how it works. So there is like a BZL file. You can see what is the BZL file. So it's like some Python code, and run. And by default, it's quite a lot of commands. Like you might want to go through a lot of stuff if you want to read through this because it's quite long. And then when you run, right, you just pyoxidizer, run for some time. So in the meantime, you just see their documentation. As you can see, like their documentation is quite long. and they have like it's quite long, but a lot of it is like API documentation and like how to use it, whether they're having like getting started guide on how to build like a Python project with pyoxidizer, and they also have some comparison with other projects. But from what I see, it's not easy to use. That's what I see. Maybe let's go back, and oh, it's still compiling. So like in one of the comparison, they say that pyoxidizer is not like preferred when there are lots of dependencies, where not lots of native dependencies, and like they compare it to PyInstaller and some other.
So what are the native dependencies? Is it something like NumPy?
Native dependency like they say like PIQT or maybe something like pandas or something
I
like that.
see.
It requires the C. So by default, it invokes the Python interpreter. You can just print hello over here. So it works. Binary.
So it's a single binary that runs the REPL of Python.
Yeah, it builds like a single binary here.
I see.
Let's check. Yeah, it doesn't point to Python or something, but it points to libc. And at the most, I got it to like the point of just running it. How I didn't check how to run with the module -m or like the file. I tried, but it didn't work. So let's see here. I'll print hello world and run the game. So it needs to build like almost a lot of things. And by default, if you use the SD cache as Rusty wrapper, it'll be faster, like from 40 seconds to 30 seconds. I mean, only if you are doing incremental changes. So when you're experimenting with pyoxidizer, you may not want to like always run pyoxidizer. You probably want to just run the project directly. And that's what I see. Slower than typical Rust compilation, like way a lot slower. Usually Rust compilation is just like a few seconds for incremental changes, but this is a lot slower. Maybe it's not using cache or something. SC previous version was slower, but they improved a bit. So this at the end, this will print like a, and it will create a binary to do that, like print hello world.
Can you do something more
hello world.
complex with it, like perhaps?
I haven't get to do like importing the modules and stuff, but probably that could be done like through this.
Can you do like a flash or a bottle side with this?
I didn't try because I didn't even get importing this module. I didn't get to a point of having this working.
Oh, okay.
Usually like you just have like hello.py, right? Print hello world. And then you can just do Python -m like this, right? But I do Python -m hello didn't work. No, I do like hello here didn't work. Yeah, but I stopped. I didn't check, and the error is not very good, like the typical Rust errors. Some conclusion not easy to use. But if you want a very featureful thing, like a very featureful packaging, this might be one of the thing you can see if you can get yourself the documentation. But mainly it's just API documentation on how to use it. So the sources you can read from pyoxidizer, read the docs. So this is pyoxidizer. Well, pyoxidizer a lot. You just playing around with it.
By the way,
maybe
we have more participants in the chat room now. So, hello everyone who joins us on Discord, YouTube, and perhaps some guys from Telegram. Hello, and welcome to Rust Meetup Malaysia, May 2021.
okay, now should we get on to the second? Should be a longer talk compared to the first one.
Any question from the audience?
Any questions?
Want to talk? You can actually type out the question on the Rust Talk chat room or just directly in the streaming. I guess we can proceed then.
Maybe yeah, we can just proceed to the second talk. Second talk, the title will be implementing third-party trait for third-party type. For those that are new to Rust, a trait is like an interface, you can say, but it doesn't contain like the data. It only contains like what is the. It only contains it's similar to interface, but they like it can have super traits. Yeah, which is similar. It's like abstract interface, so it's similar. So third-party trait means that the trait is on a third party. The trait is on another crate. A crate is like a library in Rust, and the type is also on a third party type. So on our last talk, we talked about at the end of the last talk, right? We talked about using inline Python, writing some Python code within Rust code and passing variables from Rust code into Python code, right? And then Rust part for converting the Rust code into Python code. So what this does is that there's a bunch of stuff which and yeah, you notice this part, right? There's a hack. You see that there is you see that there's a string here. The date chrono, which is the date chrono naive date, which is like a date type rather than a string type. But we are going to convert this into something to be read by pandas, to be used by pandas. But here I put each string, we can process it. But wouldn't it be good if we can? Wouldn't it be good if you can like directly to the py without converting it to string first? Because like why not just keep the original Python datetime type rather than making it feels like a hack to convert the day into like string, like the year dash the RFC 3339 date, which is like the year dash month dash day. So it feels like a hack. So a better case would be we directly convert from the Rust chrono date into Python date time date, which is a better choice. But we can't do that here. So chrono date naive date cannot be converted into a pyo3. Pyo3 is a Python integration. It's a Python integration for like Rust. It's a Py object. Py object is like a Python object. And why? Because chrono naive date does not implement the toPy object, which is in the demo. Okay, I'll show it. I'll show them. Search for naive date. Okay, how to check whether implementation for that? You can just search from the left side. Mainly around this part. You see that there's a thread implementation, right? These are like implementation for naive date. You see, oh, how come they serialize? This serialize is from cert, which is the serialized deserialized library in Rust, serialization library in Rust, like converting, like marshalling or converting between different types in different formats, like to JSON and stuff. But this is like a generic one. But how come naive day supports the serialization, but it doesn't support the Python like pyo3 object? And, or maybe you can search pyo3. In pyo, like in pyo3 conversion, let's see conversion, and then they are like from no into pi, should be into pi object, to pi object. So this is the one that is like converting it to Python object, and we check here. Do we see to pi object? No, or we didn't see to pi object, but we only see serialized, which is like it will implement the serial. So the serialized trait is implemented for naive date, but the to pi object, the to pi object is not implemented for naive date. And how? And then let's try implementing that for ourselves. And so we write the implementation for ourselves in IMPL to pi object for chrono naive date. And here, okay, this is wrong. This is wrong, but this is just an example. Let's see if it works. We do it inside our crate, our own crate. So what do you think? Omayo motion deiru.
Nani?
Wait. Boom. Wait. Boom. Nani? Okay, sorry, too fast. Okay, the joke we didn't get the joke. But never mind. So there's an error. Then like, okay, I try replicating this error. I mean this is like red, but never mind. Content. So only traits defined in the current crate can be implemented for arbitrary type. What does it mean? And you see like nice crate, and to pi object is from pi pyo3 crate. So you see that both is from different crate. But why doesn't this work? Maybe you can try. Rusty explain this. It says only any trait defined in the current trait can be implemented for arbitrary types, like this. So it doesn't work, or because rule, and this is what we'll be talking. Okay. Often rule. Okay, I repeat. Often rule. For those that don't know what is often rule, now let's explain. But before I go into that, the explanation is based on this original repo. Therefore, there's a very good explanation there. And before we go into talk about often rule, let's talk about coherence. Or I say it's trait coherence, but we can just call it coherence. Is like at least one coherence, at least one implementation of a trait, and most there can be implementation of a trait for any given type. For example, you have serialized, right? You can only have one serialized trait being implemented for the any type. For example, the type just now we want to do is naive date. Like if you have two like if you have two serialized, right? Then you choose, and there's like that they will likely cause incoherence. So any programming interface, any programming language that have like the features like trace, so they'll either do enforce coherence by refusing to compile programs that contains conflict combination. Like you implement the serialize here once, and you implement serialize for the same type in another place again. So which one, when the thread is being called, right? When the function in the thread will it run? So it'll be confusing for you. It'll be done, but it will be confusing. You need to like specify which original thread to use. So it'll be confusing. And another way is embrace coherence. Which implementation, like which thread to use for that. Although Rust have the like you can specify the original which thread from like the disambiguation of original function to use. But in this case, Rust chooses to enforce coherence, which makes a lot of things easier especially when it involves. So we can talk about often rule. That we know that Rust, right? Sometimes you all have written some traits, and you may notice. So there are two rules in often rule. So the first rule is you cannot have two implement MPL blocks that overlap. You may probably some of you all may notice this, where for example, you trait for T and another trait for T, but in Rust you can do trait bounds, right? Like debug and display. This might work, but in some cases, in many cases, right, the type can overlap. Like some types implement debug, and some types implement display, and some types implement both of them. So what will happen for those that implement both of them? They both have the same trait. Then which one will it call? Like which one should it follow? Should it follow the debug or should it follow display? So it will be confusing. So you can't do overlapping MPL or types. The current workaround is unstable. You need to use nightly Rust. And the second rule for often rule is that it consists of is often rule. And so a simplified way of saying this is both of the trait, either one of the type or trait must be from the same crate. Like the same crate you define must be there. Why? To prevent like dependency hell. So what if both crates have the same MPL or even security? Like for example, you have a secret type, there's a secret crate, but in another crate, right, it IMPL the display for secret, which you don't want. You purposely don't want the secret type to have the display trait, so people can't view the. But then what if like say third-party trait implement that, and then a user takes in both the crate, one from the secret type, the secret crate, and another one from another crate. For the secret means that the display you can print the secret now, which will be weird. Like it's like it breaks some of the stuff there, which it doesn't want to do. And other than this, right, it also allows MPL to be added. So new stuff can just be added. Like what if like already have the same MPL and then your crate add it again, and then it will breaks the overlap rules. So in our case, right, you can see it all comes from both different crates. So how solve it? You can note that I'll show some solutions that was done for. There are also other solutions like using specialization, but there is in nightly only. So both of these like viable solutions that we see. The easier solution is through new type. you can see for pyotree chrono crate. So what it does is it just wraps around the naive date in a new type, and it adds, it have all the original stuff. It delegates all the original stuff to the original implementation. And basically, okay, here they do a lot of macro. So so basically what it does is like this. You can see like a struct naive date like this. Basically, this is the original. So the inner naive date is the original chrono naive date. And this is pyo3 chrono naive date. So you can just use the pyo3 chrono naive date and the conversion between to the Python date for better pyo3 integration. This approach upstream, you can just write the separate code and you can just keep your own MSRE, like your own Rust version. And you can delegate everything and you have control. But it's not that ergonomic when you look at it, because you need to take from another crate, which like there's like 10 integration. Do you want like cert chrono, pyo3 chrono? Then it'll be weird, right? But we see that, how come chrono already supports cert, but chrono doesn't support pyo3? So it means that you can directly just put pyo3 integration into chrono, right? And so this approach may not be good if you want to do it for like the integration between popular crates and core crates like pyo3. Or pyo3 is not a core crate, but like cert. Ideally, you want to have, let's say if you have a Telegram or Discord API crate, you might want to directly add a feature to allow to implement cert for your library so other people can use, or even pyo3 and stuff. And today we'll be talking about how to integrate it directly with the library. I did a pull request, which is like halfway. So I'll discuss how we did it. And one of the main benefits we have here is it can utilize the underlying data directly. Like chrono, right? In some parts, the way they store it is in a very compact form. For the date they store it in like 2U size, and then they store everything there. But if we use their high level API, we may need to do some additional instruction. In some cases, maybe Rust didn't get to optimize it. But if we use the inner functions directly, right, we can probably reduce like the function calls. But in our case, just for this, the chrono is a bit troublesome because the minimum supported Rust version is low. Even Rust edition 2018, so it's the 2015 edition. And I think like, so we decided to change chrono upstream. But why not change pyo3? The developers in pyo3 say you can add one of the crate to either you can add it to either chrono or pyo3. Both works. So you can, if you want to contribute to upstream, so you can extend it to both sides. If pyo3 developers say they can add it to their side, that also works. And how it works is cargo features. Like when you use chrono, right, you can just specify like pyo3. You want the pyo3 feature, then it will compile that pyo3 part. So for those that doesn't need this pyo3 integration, right, this will be, so it makes use of the cargo feature flag. As in, it can only compile when needed. You just need to specify that you want this. But is there by default. I think it's there by default. Oh, it's optional. So I just added this line. to their cargo terminal. And how to use the new feature if it was added to this implicit feature. Usually you want to have like a feature PyO section to add this new feature, and this is just a dependency part. So implicitly, this will create a new feature. You do it. This is the feature flag. I see that the existing code that put it inside a module. Just put a new module there. And the CFG is for conditional. This is the macro for conditional compilation of feature flag. So in this part, like say, if feature is enabled, this part will be compiled. So this part will be, if this part is compiled, right, means that now your code support. Now naive state supports to PyObject. So you can see that we can make use of the internal methods. That MDF is one of the internal like a private function within naive state, and we can directly use the MDF month and MDF day directly, and we can construct a PyDate. And then we also skip the other parts because it's the same. We just do some processing. This is just converting to Python object, and other one is just converting from Python object. Yeah, so this now you all should understand like why can't you just implement third-party crate for third-party tag, because there is something called orphan rule. And yeah, it is not done yet. Even the new type one, they just do like they just do some simple thing there to not for it to work, the PyO tree. That one is quite. Yeah, we just like put into the original like file. We just add, so like the date is here. We just add the implementation here, and the test is also here. So this is how it works. Is there any question?
Do you have any example code that shows us how this works?
How this works? What do you mean? Like after ended, right? Is it?
Yeah.
Okay. Right now I don't have sample. I have, but I probably can't show that. So you see, right? Once we implemented that, we don't need to do this. We can just throw this away. So when we do to PyObject, right? No, previously we can't do to PyObject directly, is because naive date is not implemented for like the from Py like to PyObject. But after we do this, right, we can just directly throw this away. So we can just have self.day to PyObject. Then it will directly convert the naive date into the Python date time.
Okay.
So it'll be like this. So rather than this, you can just do like this, and then the type will be like the type will be like, don't need to do type here. It will be type in, the type will be inferred, but the type here will be should be type any something. So this is similar to the original chrono implementation, because if you see, the cert is just here, just nearby. So it's like you can just use the cert function directly from chrono. Like in chrono, you can just do. Okay, for example, in chrono, you can just do this. Maybe I can just show. I added 3 dependency here. Okay, for example, I want to add like okay, I want to serialize the chrono date into JSON. This is not the original like the conversion into PyObject, but I just show serialize because serialize is the same thing. Is a third party trait. So I'll just do a derive serialize. Okay, just call it bomb. Bomb, and then okay, detonate time. Okay, if you want to write to case what? Forgot. I forgot what is that called, but never mind. Just do here. Detonate time will be like naive time or date time. So the bomb will be bomb equals to the bomb will be detonating in like okay. Oh no. Let me see. So just use now. Docker now. Okay, I'll import from everything from Chrono. I just disable this. And this will be date time. Okay, Chrono, regarding Chrono, they have like a naive, you see why there's naive date and naive date time, right? Naive date time is the date time without time zone. And date time have time zone. So we want to put local here. So we just do local now. And add, can we add? Date time. And we add. Okay, we can add duration. Add the duration. So local now add duration. Where is this duration? Okay, duration like in 5 minutes. Do this, 5. For no duration, I need to import it. And the bomb will detonate in 5 minutes. And search JSON. I just do to string. How to use. I'll just print it out. Print the JSON out. And the convert is lowercase. How to do that? Convert, rename all. So rename all. Camel case. If you want JSON, we want to rename all to camel case. We do a check. The string. Oh, is a result. Alright. Okay, run. So you see like detonate time and is so you see that chrono, this is serialized. What this does is it will generate a serialized thread for bomb. And yeah, it's a bit hard to explain how they have serializer and serialize. This is a serializer. This requires the stuff to be serializable. And this part, and it won't work, right, if datetime doesn't support cert. This won't work if datetime doesn't support cert use case. So let's say if I remove the feature, right, let's say if chrono, I remove the feature, and then you see that it won't work. Like serialize is not implemented for this. So now you see like the use case is like the integration is like smoother. You can directly just use the serialized crate, the serialize for the original stuff. So this is the cert chrono, and then you need to import rather than chrono you use cert chrono, right? Then you can just do like just add a feature here, and then this will work. So it will just give you the detonation time in minutes. Yeah, so it's correct. Any question? Yeah, this is quite for this. I like this, quite useful. Yeah, we name every like the what is this called, snake case to camel case, everything inside here. You can do it on here, but yeah, I just do it. Any question? What is the use case of this? So it just provide the crate. It just implement the crate. That's it. But it gives a better integration when you are using different stuff. Yeah, I'm frozen.
You're not frozen. Hello, I see some new faces in the chat room. Hello, everyone who joined us today. Okay. Any questions to ask from the live audience, live participants, and
Any question? Can just talk also can. You can type in the chat. I cannot
yeah.
see only. You can just talk.
If not,
What-
we will
you
stop
want
the
to
stream.
see.
Then we will do some more chat.
I also do this. You want to see this? Okay, maybe in the meantime I can explain like there's local C and there's fixed time offset here. But chrono is a library. The time chrono is like a most popular time library. Not very featureful because it doesn't support IANA, and chrono only support fixed time offset, which the people say is bad. But it's good enough for UTC stuff. Like good enough for like the RFC date, the ISO 8601 date, or the RFC 3339 date. It's good enough for that. But it doesn't support local. It doesn't support like different calendar system. It doesn't support that. Like it is already built with Gregorian calendar in mind. Like the date is just the Gregorian date. I'm pronouncing it correctly. So this is like a generic. The local is the local time and UTC is the UTC time. They differentiate between that, but it's not like all features is there. It's 0.4. Like 0.4. But cert is more featureful. So almost everything is there.
see any questions from Zoom and YouTube. I guess we can stop the stream now, then we can talk a little bit more. If you are interested in joining in Discord chat room, please go to our Telegram chat room to get the link to Discord. We'll see you again in July, and hopefully everything gets better then. Stay strong and stay safe, everyone. Bye bye.